Hi, welcome to the session. I'm super excited to have you here, and I know, as I just said to the people in the crowd, this is not a session you'd normally go to, especially at a conference like this. And to give you a little background, my name is Joseph Griffiths. I'm a double VCDX, so that should give me technical chops in the room, right? And I'm going to talk about operational debt. And there's a reason I'm talking about operational debt, because for the last 3 years, I stepped away from deep technology and started talking strategy with our Fortune 100 and 500 customers. And from those conversations, it's essentially led me to believe that there is a core problem at many of our customers. And I think you have the same core problem. And there's a pretty simple way to solve it, but we're not making investments into solving that problem. And it really is operational debt. So, I like a little interaction. It's that time of the day. Raise your hand if you have debt. Yeah, there's nobody in the room who doesn't have debt, right? Thank you, appreciate that. Oh, I'm sorry, I should have raised my hand. I got a crap ton of it, right? So we all understand the idea of debt. So when I start to talk about the inside of debt, it's an interesting conversation, right? I want to talk about operational debt. Now, I think everybody throws around the word technical debt often. It's a regular conversation. But I think operational debt is a little bit different than technical debt. So for me, it really comes down to every time you do something, there's a tail of maintaining it. This is where our lean manufacturing process changes. Toyota makes a car, Toyota kicks it out of the factory to a dealer, the dealer sells the car to you, and who maintains the car? The mechanic, not Toyota. In our world, when development finishes their product or their development action and kicks it over the fence, we operate it for 3 to 5 to 10 years. We have to own the end product. So we incur compounding debt for everything that we do. And we're so focused on initial state that we don't solve that problem. So, I like to think about this for people who really run into this problem. So for me, it's a simple story to use Google because it's a well-published story that you've heard of many times before, right? So Google spent a bunch of time making a software-defined abstracted environment. Everything was software-defined. They used microservices, containers, all that stuff. And they started deploying all their services on this so they could have geo-scalability. And they looked at their challenges. And the challenge no longer became, can I provision? Because you could provision 100 million of those, search, right, a minute. The problem was, how do I operate those? And so they started staffing people up, to operate and maintain search. And they realized that they were going to eventually become unprofitable just from the operational cost as they scale up. That it wasn't a linear, but it was a compounding challenge. Because as they start to scale up in different geos, if they start to scale up in different areas, their problem becomes compounding. I need a team there, I need people there, I need professionalism there, I need people who are trained in our unique method of doing everything. And so, they decided that they had to make investments in automating operations, all the day 2 stuff. All of us have heard about SREs before, I assume at this point. That's where the SRE initiative came from, right? 50% of your time automating, while 50% of your time running. So you knew what the real problems were. What you do during the 50% of the time manually, you go automate that 50% of the time. If you think about this, it's really interesting because they projected that they would eventually be unprofitable within 2 years. So they started this initiative. They found out they were unprofitable within 2 months because of the growth model they hit, right? So much needed initiative, solved a lot of problems for them. Now, in a lot of enterprise customers that I deal with, the Fortune 100s, 500s, what I've identified is that most of them haven't actually automated the operations. They've gone a different direction. They go to other countries and hire lower cost people to be tier 1 operators, right? And this is even worse. Why is this worse? Because they're going out and getting people who are paid to close tickets. There's not quality in that model, there's not benefit in that model, and there certainly isn't knowledge transference in that model. So there's no way for them to capture the data from that to figure out even what they should automate, because those people change in, change out, and regularly change. They lose all of that institutional knowledge. It's gone. Where the Google model, they were gaining more and more institutional knowledge because what was happening was those SREs were starting to tell the product teams, you know what, there's a problem with your API here on the software-defined networking. You got to fix this because we can't automate fixing this problem right now. They started creating feedback loops that were extremely powerful. So the model that most of the customers I deal with are actually creating more debt. And it's exponential. They grow, the staff grows, right? It just keeps going up and up. So I like to think about the real impact of operational debt. Every single day I meet with CIOs. I've had 2 meetings in the last 2 days with CIOs, and they told me the same thing. You know what I really want? I want agility. Please raise your hand if your boss tells you you want agility. Yeah, there we go. So 50% of the room said they want agility, right? I hate that word. It's totally unmeasurable, totally unknown what it means. But as I've thought about the root cause of this problem with many of my customers, what it really comes down to is they want to be able to have staff that have the time available to pivot and take action, to do things. And what stops them is because they're reacting too much to all the operational problems. They're constantly reacting to everything that comes through. So they become the turtle in the world, right? And because they're the turtle in the world and they're slow, that's the real impact to our agility. If we can get ourselves out of those operational things, we start automating, we start making them go away, then we have the ability to spend the time pivoting on the things that we really should be spending time on, the innovative things, the things they want to. And to me, that's agility, because the truth is, today's agility is tomorrow's not agility, right? That's how fast we should have it last week. Now tomorrow we want it faster. It's a never-ending cycle, but what it really means is you need time to do the work. There's also a scalability challenge. There's a lot of things changing. And I will tell you what's changing is it's not becoming less complex. It's becoming more complex. And all those changes that add to the complexity of the solutions that you're having to deploy and maintain create compounding debt. That's just the way it is. And it's going to continue to happen. So we have to have a way to fight against it. Debt's never going to go away. There's no way to pay off your mortgage in this process. Because as long as you're creating new, you got more debt. But we can start to pay it off in a way that pays off for us. And I'd like to illustrate this. This really simple graph, okay? I love this graph. So the green line, the blue line shows that we start out in year one at roughly $450,000 is our cost for whatever. What it is, I don't care. This is just an illustration, right? So your operational cost today is $450,000. We're going to assume that your operational environment and sizing grows by 5% year over year. So at the end of 5 years, you're talking about close to $700,000. Now look, with the customers I deal with, you should probably change that into millions and some of them billions, right? The number doesn't matter. It's a simple graph to show you the point. Now let's assume that we instead make an investment where we decide to automate 10%. 10% of what we have. So we're only automating 5% really because we're growing 5% every year, right? But we have a compounding interest because whatever I automate this year, I don't have to automate next year, no matter how big I grow. If I grow by 25% next year, it's already automated, it's free. So let's just assume this linear goes there. You can see that we've taken it down to close to 300,000 over 5 years. It's a simple graph. Your investment makes a big difference in your operating expense. Now, people are going to say to me, I'm worried about losing my job. No, trust me, there's plenty for you to do, which is the stuff you should be doing that drives the business and it gives you better worth than the operational debt that you've been doing right now. And I want to talk about a couple different trends. So this is the interesting bit. First of all, everyone in this room is going to go, well, there's some trends out there beyond the go hire low cost people that are going to affect this. So I want to talk about 3 trends and their impact on this conversation. The first one is public cloud. Raise your hand if you've got something in public cloud right now. 95% of the room. Good. Me too. My blog runs in public cloud. So, and I work for VMware, so they have a lot of stuff in public cloud, right? Public cloud is a really interesting challenge because what essentially public cloud providers like Amazon, Azure, and Google have done is they have pulled away a lot of the hardware debt. You don't have to worry about replacing hardware in those cloud environments. So they have removed some operational debt around hardware, right? And some of the software layers, especially if you go into certain public clouds where they have various value-add unique features. I'm talking about Lambda and auto load balancing and preferential treatment for SQL Server and stuff like that, right? We all get it. There's unique features and capabilities. RDS. I don't have to run a database anymore. I'm just worried about the data. There are things like that that start to remove operational debt. So there's good things. But if you think about it, what really enabled all those good things is everything is defined in software. Because all they've done is they've defined everything in software, used the ability to deploy it in software, and then they operate it in software because they can interrogate it software-based. So the real lesson of public cloud is everything has to be software in order to work so that we can start to remove the hardware from the conversation. Now, I'm not against public cloud at all. In fact, I'm a big fan of it. So there's a value that you can get from public cloud, but the real challenge in public cloud is you still own the long-term stability. After you deploy that AC2 instance, for the 1 month to 10 years it exists, that's your problem. They're perfectly happy to let you deploy another. But what runs on there that actually provides business value is your problem. So you still have operational debt, application, operating system, all the stuff you've been dealing with before. So public cloud doesn't make operational debt go away, it's just a mitigator, right? It's a better mitigator than hiring low-cost people to do it in another country for you for that particular feature. Honestly, it is. Because at least you're saying, someone who does this at hyperscale, go do this at hyperscale. Right? You're really good at operating the hardware layer, go operate it for me. I don't want to do it. So the next thing is automating provisioning. I'm willing to bet that every single one of you has some sort of initiative or has had some sort of initiative hyper-focused around automating provisioning. And it goes like this. We used to take 60 days, now we take 1 week. We're trying to get it down to 14 hours or 45 minutes or 45 seconds or 45 nanoseconds. It doesn't matter, right? We're trying to get it smaller and we're focusing on provisioning. Why do we care about provisioning? Because it's inherently the bottleneck that pisses off developers, right? The developer, once they have a server, don't care because they're just going to keep dumping their code. They can keep changing their code on it. They don't care how much of a pain it is for you to operate off that. But if they got to wait 60 days to get that server, that's a big problem. So what is automating provisioning really about? It's about meeting the needs of your consumer. But it creates operational debt. Why? Because we've reduced the process time. You used to have a 60-day bottleneck that gave you a lot of time to do the operations on it. Now you have a 1 day, a 45 second, a 45 nanosecond time before they deploy, right? And so the real challenge we have is it's completely ignoring post-deployment challenges that we have. And the exponential problem that I just mentioned to you increases. If everyone in your company can provision on their own, you have an exponential increase in the number of things that you have to have debt build upon. I've actually increased the number of people building debt for me now. So this problem, albeit solves a business relationship problem, which is a big deal. I don't want to take that away from you. That's important. It creates an exponential debt problem for you because it puts more pressure on you. The idea was, well, I'll be able to build it faster and then it'll be in their camp and their problem. Let's be honest, that's what we said to ourselves, right? Doesn't work that way because as soon as it breaks, it's your problem, even though they've built it and you didn't even know they built it. Okay? The third trend I'd like to talk a little bit about is, check my time. The third trend is microservices and containers. I think you might have had to been blind and deaf not to be able to hear about this week, right? I think we got some serious Kool-Aid going on from my company on this conversation, right? And I'm a huge fan. I love containers. I love microservices. I talk about them all the time. I help people architect applications into them, transferring from traditional applications into it. It's a great conversation. But you know what is really true with containers and microservices? They're dynamic. So where a server likely exists for 2, 3, 5, 10 years, a container might exist for 27 seconds. So all of your traditional management methods that you used to use for virtual machines that assume that it's going to exist for a long time no longer work. And the scalability is massive. If you listen to our keynote, we talked about how many, we have like 1,500,000 VMs that VMware deploys and destroys every week, and we have 500,000 containers. Next VMworld, it's going to be like 5 million containers, I guarantee it. It's going to go inversion, and we're going to destroy millions of those every day. That dynamic nature is really crazy. So the first thing about containers that's kind of important is that the immutability idea. Hey, if it's misperforming, just throw it away, or just delete it anyways and remove it. That's a pretty common construct, and it works. But the reality is anything that has business data on it is what really brings value. So a web server is great, it provides a customer the ability to log in, do something, interact with your company in some way. But the truth is, that transaction, that conversation is stored in a database somewhere or some sort of data storage. That persistence has to be somewhere, right? And that's where the real value is. So there's a good portion that we can do immutability. And if we add immutability to containers, that removes a lot of operational debt. Not working well, delete. Not working well, delete, right? That is very much like the public cloud hardware conversation. It actually is a good thing. But there's still a point where data lives somewhere, and that's the part that you've got to preserve and maintain, and you have the same operational debt problem, and it lives in a construct that could be recreated at any time with the assumption that the data gets preserved. So immutability doesn't solve our problem, it just is another way to mitigate operational debt if you think about it, right? The other thing is that microservices and containers has changed the world in the way that we consume. We've seen that very clearly this week, but I'll just bring it up now. Declarative. I want this image, 6 of them. I want a load balancer in front of them. In the middle, I want this image, 9 of them, with a load balancer in front of them, and I want this data tier. I just built a 3-tier microservices application. I'm not sure I would do that normally. In fact, I probably wouldn't, but to give you the idea, right? And I declare all that in one file and say, give me one of those. That declarative model of, I don't care what load balancer you use, and I don't care how it's configured, and I don't care what VIP it gets, all of that I don't care conversation is extremely powerful. Tell me what you want, and I, as the engine, will make the best decision inside of my infrastructure to deploy that as it needs to be. So declarative is actually something we take away from this as being really good. Something that solves a lot of operational debt, because if I can recreate with a declarative statement the thing that has the unique value, besides the data layer, that solves a lot of debt for me, because now I really can throw away a lot of it and recreate it. So there's some good things there. Does it solve all my problems? No, because the truth is I'm going to deploy 500,000 of these a day and destroy that many too. That's a lot of change, right? You can't even manage that right now without having all the management become automated. So that's where automated operations come in, right? One way or another. So look, I said this is all about removing operational debt, and I've just been having problem statements for you so far, and I hate that when that happens. So the other part of my job is I help people build roadmaps to solving problems. You have a problem, build a roadmap. So I'm going to go through 5 steps that will help you remove this, that I've done with a number of customers, and they've seen really great results. I can, by name I'm not allowed to mention them to protect the innocent, but I can tell you there's things like 7,000 less tickets a day, 10 FTEs less people needed to do that work every day. That kind of conversation. Now, the great thing is the company that did the 10 less FTEs, they didn't fire those people. They took those FTEs and they assigned them to taking out the rest of the operational debt. And so when they freed up more people, they did it. So they're not doing 10% year over year, they're doing 20 now. Next year, they'll be doing 40. Till they get to the point where they're 50, and then there's a point where it doesn't make any sense anymore because there's a lot of human intelligence involved, but they're driving down their number by reinvesting. So it's not a job loss, it's go build automation for me. It's a funner job anyways. It's a lot more interesting than, rebooting a VDI instance for 50,000 people a day. One of the things they were doing, right? It's crazy. 10 people rebooting VDI instances, recomposing a day. It's an API for that. Let's fix that, right? All right, so first of all, we learned this from public cloud, we learned this from microservices. We need a way to be able to control all of the objects that we're going to deal with in order to provide the value to a service in a software-defined way. If you've got to rack it, if you've got to stack it, if you've got to type on the CLI, you probably can't do this. You can't remove operational debt from it because a human has to be involved in it, right? So software-defined abstraction is critical. That is why the hardware removal was possible for public clouds. That's why everything is moving in a declarative state, because I can write a declarative statement that I want this configured, but to get my network people to type that on there's a translation layer of human error there, right? It's bad. So software-defined abstraction is first. Does it need to be everywhere? No, but it needs to be pretty prevalent or you're not going to operate it. So most of the people in this room probably already have compute virtualization. So you can automate operations around compute. If you have storage virtualization, you can automate operations around that. If you have network, same thing, right? Doesn't mean you don't have to have it all, but you have to have some of it or you can't automate it. That's the way it works. The next one is identifying toil. Pretty common lean statement. Everyone's pretty familiar with this. But look, you're going to look at all your operations that you're doing, all your ticketing system. That's usually what I do, by the way. Dump your ticketing system for the last 3 years. And let me look at what kind of tickets are common. And I'm going to look for 3 things. Is it repeatable? In other words, when you get this ticket, do you do the same thing every time? And is it happening a bunch? If you only do it once a year, no point in automating it, right? Just not worth it. If you do it 10 FTEs all day, every day, 7 days a week, yeah, that's prime. Let's automate that, right? Number 2 is no human judgment. In other words, if you know the answer to what you're supposed to do every time and how to deal with that problem and no one really has to think about it, then there's no human judgment involved, because automating human judgment gets into these crazy design trees that are impossible to maintain, right? That's painful. So there has to be no human judgment, and then it has to be interrupt driven. What does that mean? That means that you don't proactively do something, you don't think about it, you get a ticket and you act. That's interrupt driven, right? It interrupts your work and drives you to do something. So those are the 3 things you have to look at for toil when you're starting to identify what tasks to do. So you have software defined, you have toil identification, so you're going to find the stuff that's toil, and you're going to go automate toil. Super hard, right? Pick the one, automate the one, take the people who are doing the one, have them automate the second one. That's it. It's an investment process. Then we move to declarative. Now this is an interesting one. So far I've been saying take what you currently have and automate it. Have a nice day. But how do we avoid having operational debt going forward? Remember, it's compounding. It increases year over year. The way that we do that is we have to change the way that we provision. Why does this matter? Because when we provision today with our automated provisioning, we create an initial state and then it changes. If we use declarative models, we can say this is the desired state that I want to have and check it against it 3 months later, 6 months later, 9 months later, a year later. And if it's changed, fix it. So now we have configuration management, right, that goes all the way across that. That's super powerful. And if you want to change the architecture, change the declarative statement, it'll change the architecture by doing that, by updating it, right? It's not desired, go change the desired. So moving to declarative is one of the best ways that you can remove future operational compounding debt. Because it's not enough just to automate it, because it'll be a never-ending process. You've got to change the way you're doing it in order to really get ahead of it. So that's step number 4. And step 5 is super simple. Keep going. Don't convince people that this is a one-time event, that you're going to do something and it's going to be a big win and you're going to save them a bunch of money. No, this is an operational change that you have to do year over year over year and continue to invest in. So the Google story I showed at the beginning, the operational side of Google, the whole company, 1,500 people because of this. So they have 1,500 people who run all the operational side. That's not development, right? That's operations, keeping search, Gmail, all that stuff up. 1,500 people, and those people, 50% of their time are spent automating, 50% fixing manually. They've got an extremely, they've continued to make that investment and will continue investment, but that scales. Look how big they are. Because every dollar they've spent on that 50% automating is a dollar they don't have to spend in the future as they grow bigger and bigger in scale. So there's the one for you to take a picture of to remind yourself if you want to take a picture, right? Is all 5 steps together. It's pretty simple. It's not hard. If you have a ticketing system and you're capturing work there, go mine the ticketing system. It's simple. And you ask these questions. How often do they do it? Does it require human intelligence? Is it interrupt driven? And my favorite, how long does it take to manually do this? If it takes 3 seconds, it's hard to automate and benefit from, right? Unless the frequency is so high, it's unbelievable. But you're going to find that if you really have a real conversation, almost every ticket takes 20 minutes. Because you open the ticket, you read the ticket, you orient yourself, you locate the resource, you take an action, you close the ticket. All that could be automated and done automatically by the process. And that is the end. Thank you. I believe I have 5 minutes for any questions you want to ask. If not, we're done, and thank you for attending. I appreciate it. I've got my cards. If you want the deck, I'll be happy to send it to you, but I don't know how much help it's going to be because it's a bunch of pictures.